Hello, I welcome you to this exciting video and the topic acids, bases and salts. In this video we'll be discussing reaction of acids with bases and alkalis. Okay, so in our previous video we looked at the physical properties of acids, and here we discussed a number of things. We said that acids are simply have these following properties. Okay, they have a sour taste, they are soluble in water, they turn red litmus paper blue, which we demonstrated by this simple experiment here. Acid have a solution, so acid solutions have a pH which is less than 7, okay, and most acid solutions are corrosive. Okay, and all dilute acids conduct electricity, and we said this was due to the presence of different ions. You have both cations and anions. Okay, so the presence of opposite charged ions in the solution causes the acids to be what? To conduct electricity. Okay, so now in this video here we're just going to look at reaction of acids bases, reaction with acids with bases, the reaction that occurs when an acid reacts with a base. And also we're going to see, since we already looked at the reaction of acids with metals, if you haven't watched that video, please watch the previous videos under acids, bases and salts, the reaction of acids with what? With metals. So acids react with bases and alkalis to form salt and water only. The reaction between an acid and a base is called neutralization, and we're going to see why the reaction is called what? Neutralization. Okay, so salt and water only are the only things that are produced. Okay, so let's see what we're talking about here. We are saying that if you get an acid, you react with a base, you should get only two things, and that is salt and water. Okay, salt and water and water. Okay, and the name of this type of reaction is called neutralization. Okay, the name of this type of reaction, we call it neutralization. Okay, now it's called neutralization. Neutralization, this is just an English word which means, it comes from the word to neutralize. Okay, and to neutralize is simply to get rid of the chemical properties of something. Okay, for example, certain things that we are able to neutralize are things like poison. Okay, you can neutralize the poison. Okay, so even acids can also be neutralized by bases, and the same thing, bases can be neutralized by what? Acids. So you find that these two, they work in opposite to each other. This can neutralize a base, and this can also neutralize an acid. Okay, so the whole process is called neutralization. Now when the neutralization has taken place, the only things you are going to get is salt, okay, and water, and these two are basically harmless. Okay, they don't have any properties. They don't have acid properties, neither do they have base properties. Okay, they have neither acid nor base properties. Okay, so now the topic of our day, we said the reaction between acids, okay, with what? Bases and alkalis. So we need to understand the difference between bases and alkalis. So first define a base. A base is a substance which reacts with an acid to form a salt, and this comes from the chemical property of an acid. Okay, but sometimes we define it as an oxide or hydroxide. Oxide meaning most bases, they contain the oxide radical or the hydroxide radical. Okay, so you'll find either the oxide radical or the hydroxide radical in a base combined with a metal. For example, when you have calcium with an oxide, this is called calcium oxide. This is considered to be a base. The same thing, you can have calcium with the hydroxide, okay, this is also considered to be a base. So here we are saying a base can also be defined as an oxide or hydroxide of a metal, and they are called proton acceptors. Okay, we are not going to go into details on that one. Okay, all right, so we are saying a base neutralizes an acid. Okay, that is the other point which is here. A base neutralizes what? An acid, and the reaction goes neutral. It's called neutralization. So now we said, what's the difference between a base and an alkali? So alkali, these belong to the class of bases, but an alkali is different in the way that it's soluble. Okay, so when a base is soluble, meaning it dissolves in water, it means that the base is an alkali. Okay, so an alkali is simply a soluble base, and most alkalis, or all alkalis, they contain the hydroxide ions, the OH ion. Okay, they contain the OH what? Ion. And the definition of an alkali, we say that an alkali is a substance which, when dissolved in water, will produce hydroxide ions as the only negatively charged what? Ions. Okay, that is the definition for an alkali. Okay, so at least you know now the difference between alkalis and the bases. So acids can react with both alkalis and bases. Okay, let's look at something interesting. So when you look at this table here, you can see that all oxides and hydroxides are all bases. Okay, all oxides and hydroxides are what? All bases. Okay, hydroxides are bases, oxides are also bases. Okay, now on the part of hydroxides, if the hydroxide happens to be soluble in water, okay, it's called an alkali. So that is how alkali actually come about. Okay, but there are hydroxides that are actually insoluble. Okay, these are not classified as alkalis. Okay, we call them basic hydroxides. Okay, and again, on the part of oxides, if it is soluble, it is called an alkali. Okay, if it's insoluble, it is called a basic oxide. And we're going to discuss this in great detail when we discuss what we call bases. Okay, so what do we learn from this? Okay, what do we learn from this? What's our conclusion? Okay, so we can conclude that all alkalis are bases, but not all bases are what? Are alkalis. Okay, so that's our conclusion there. All alkalis are bases, but not all bases are what? Are alkali. Okay, so now we understand the difference between bases and what? Alkali. So now let's look at what we are discussing today, the reaction of acids with bases as well as alkalis. So here we're trying to demonstrate how a base will react with an acid, and how an alkali as well will react with an acid. Okay, so we have two examples here. The first example A here, we are reacting sodium hydroxide. Now sodium hydroxide is a base, and what type of base is it? This one, it's an alkali. Okay, sodium hydroxide, it's an alkali. So we are reacting an alkali with hydrochloric acid, which is what? An acid. Okay, and here we get sodium chloride, which is a salt. Okay, so in our previous video we learned how to come up with the name of the salt. We said the name of the salt will come from where? The first name of the metal, which is sodium, and hydrochloric acid, we said it always becomes, it will donate what we call chloride. Okay, so sodium chloride, remember, plus water there. Water is always given out in a neutralization reaction. Okay, so when this reaction takes place, we've also shown it in Wade equations. Okay, going to the Wade equation, This is how you write sodium hydroxide, and this is hydrochloric acid, and you get the salt, sodium chloride, and what actually water there. Okay, now this reaction, for it to take place, you can see that you have to react a base with an acid to get a salt and water. Okay, so similarly here, this base here belongs to what we call hydroxides because of the hydroxide, which is the OH group, the radical. That's why you see here sodium contains the hydroxide radical. But that is different in the case of copper 2 oxide, because here we said all oxides and hydroxides are all bases. So some metals are combined with oxides, or some are combined with hydroxides. So for example, copper 2 oxide, which is written as this, okay, reacts with dilute sulfuric acid to get copper 2 sulfate and water there. Okay, so you notice that in each of the reaction you have here water is given out, okay, and here the acid is neutralized by the base, and we're going to go into details how that neutralization reaction is actually taking place. Okay, so just to make sure whether the equations are balanced or not, we always need to deal with the balanced equations. Okay, so let's check if the equations are balanced. So we start with this one. So we have one atom of sodium, one atom of sodium, one atom of sodium. Oxygen, you have one atom of oxygen there. Hydrogen, you have 2, 1, and this one here 2, and you have 2 hydrogen atoms there. So everything looks to be actually balanced in the first equation. Let's go to the second equation. You have one atom of copper, oxygen, you've got 1 plus 4, that's 5 oxygen atoms. Again 4 plus 1, that's 5 oxygen atoms. Sulfur, there is 1, which is here, and sulfur here, there is 1. So again, this actually equation is also balanced. Okay, the atoms on the left and the atoms on the right are all balancing. Okay, so this is an example how acids react with with bases. Okay, we could look at other examples. Okay, so how do you know whether a substance is a base or not? Either it's going to have the hydroxide or the oxide. You automatically know that is a base. Okay, and for the acids, you just need to memorize them. In our previous video, the first video in introduction to acids, we looked at a number of acids, and one of them was hydrochloric acid, sulfuric acid, and many other types of acids that we discussed that particular day. Okay, so now let's see if we can get different substances other than the ones that I've given as an example here. So now, in a case where you are told to react, let's say we use a different base, let's say calcium hydroxide. Okay, so calcium hydroxide should be written like this, plus an acid here we can use is hydrochloric acid. Hydrochloric acid is HCl. Okay, right, so these are aqueous. Okay, now what does this give us? So what happens is this, how are these reactions formed? Do they form? Okay, so this will split. Most of the reactions involve splitting of substances, so these will split together. Then this calcium now will exchange, it will replace the hydrogen here, and here you are going to get calcium what? It comes here where there is hydrogen, so you get calcium chloride. Okay, plus now this hydrogen combines with the OH, and here you are going to get H2O, which is actually what? Water. Okay, which is actually water. Okay, and here you say that actually your equation is done. Okay, they are not balanced, but the equation is done. So that is how you form. So that's the same thing that is taking place in these other reactions that we did. So this will split here, so this will split there, and then this H would displace the it's more like what is going on is this H comes here, it replaces the H on the acid, and so you're going to get sodium what chloride, okay, and then this H just combines with OH to give us H2O. Okay, so similarly again the same thing, this will split, this will split here. Okay, the copper replaces the H2 here, becomes white copper 2 sulfate. Okay, and this H combines with this one oxygen to get water. Okay, so that is how the reaction actually proceeds. Okay, so if you have any questions, please leave them on the comment section so that we can explain further if you didn't get what I was explaining here. All right.